LinkedIn echo chamber. This is ML's like Teen Spirit. We've got Warren back today. Warren, how are you doing?
I'm doing great, John.
Good. Thanks for coming back. So Warren, multi-time chief data scientist, Cardlytics, UPS, Home Depot, Best Buy. You've had a stellar career. And today you've recommended your own topic for us to talk about. So when I asked you, Warren, have you got something to say? You said, yes, integer programming. So you sent a shiver down my spine because I haven't looked at this since bachelor school. So we're going to let you lead this discussion if it's okay, because I'm terrified you'll expose me as having a zero knowledge of the topic. But could you introduce integer programming for everybody, please? I know it's an area of optimization. So introduce it, like what it is in sort of layman's terms. And then if we can move on to some of the use cases you've seen and so on, that would be great.
Sure. So optimization modeling, specifically integer programming, because a lot of the real world problems are done with the specific subset of optimization called integer programming, are there because most decisions in business and industry are grounded in this balancing act between limited resources and a specific objective. For instance, a company might have a limited budget, or they might have limited resources or time or material, but at the same time, they have a specific objective in mind, like maximizing profits or minimizing costs or meeting some type of customer demand. So integer programming is ideal for this in these real world problems because it directly incorporates these constraints and the objectives. It's a formulations designed to make optimal choices and calculate the best way of doing something while adhering to these limits or constraints. Has lots of variables, lots of constraints, an objective function, and it can be number of products to manufacture. It can be the delivery route that a transportation company takes, or it can be a schedule for people, crew scheduling on an airline. And these are discrete choices, and there are so many of them in industry. And this structure of integer programming is highly practical and relevant across all industries.
Well, let's get down to it, Warren, because when we prepared for this, you told me about your time at UPS. You told me they'd been delivering mail for 100 years. So they must be pretty good at this. But how did integer programming help? Let's go through I get the idea of there's lots of variables, there are these constraints. Let's fit it into that delivery example. So what are some of these variables? What are the constraints that the delivery business is under? And what is it they're trying to make better and optimize?
So I think that most people will think of the traveling salesman problem as the standard. A salesman or a delivery company has a certain number of packages that they need to deliver, and they need to hit them and come back to the origin in a minimal, something that minimizes the route. And the traveling salesman problem is very famous. It's very hard to solve. So that's what people will typically see or think about when they think of, say, UPS delivering packages. There are also other optimization problems that are tangential to all these things. So it's not just vehicle routing, which can get even harder with vehicle routing with time windows because you need to deliver a package at a certain time. Those get harder and harder and harder to solve. But another one that you would think that even at a company as big and as technical as UPS, we were trying to. Some of our packages would move on rail cars to get across the United States cheaper. So we needed to rebalance those empty rail cars to places where there's more packages coming out of a city and going to another city, and we needed to rebalance them. And that was another optimization model of trying to get those flat cars back to where they needed to be. And when you moved one to another place, it actually changed something else in your network. And that was an interesting problem that our transportation finance was trying to solve, a little less technical. I happened to write a optimization model that got the right answer for them, but did it in a way that they understood. So I gave this was in the early 2000s, an Excel front end to an optimization model. They understood it. they were able to do things, and we saved millions of dollars just by making a few better decisions.
A question for my interest, Warren, that we didn't prepare for.
Okay.
Is there anything that you can think of where a consumer might be on the end of an integer programming solution, but they might not realize? So some experience in their life. So the mail comes, we've done that one.
Yeah.
Is there any other data, I don't know what, when someone interacts with, I don't know, a shopping cart or a social media or goes into a retail brand, is there anything you can think of that's like a really popular application of it, but a consumer wouldn't necessarily perceive it as being an optimization problem?
Sure. I think there on like a tangential receiving end, a lot of the staffing and scheduling for airlines is done through integer programming. Production scheduling for making things in a factory is done through integer programming, and so those supply chain is typically integer programming. Warehouse optimization, a lot of network design. The cell towers are what is the minimum number of cell towers to cover the maximum area. So that's the optimal placement of cell towers. So I think, and there's integer programming that comes into pricing. So you're on every consumer is on the receiving end of some pricing where you're trying to maximize either revenue or profit, considering things like demand elasticity or consumer demand or competitor pricing, or maybe the stock levels, things like that.
Warren, do you have a forecast for this area? Like where's it going to go? What's going to happen to this area?
Yeah. So the reason I wanted to talk about this is that in my career, I've done optimization, machine learning, and AI. Well, optimization starts with the things that people already know about the process. Is that I can't spend more money than I have. That's a constraint. If you think about, if you were trying to do that with machine learning, it would have to learn that it can't spend more money than it has. But you can I can't spend more money than I have. I can't make more things than the customer. Well, I could, but I shouldn't make more things than the customer's demand. I can't deliver more packages than I have in my truck, things like that. So those constraints that you put in there have to be modeled in a certain way. And then you can make a best decision. So I think that it's that barrier to entry. And where I see us going, the forecast is that instead of needing all of this knowledge to just get started, generative AI can help business domain experts who don't know that much about optimization write these basic models. And so, my vision in the next few years, and some others are working on this, and this is a project that I'm working on myself, is that imagine if, as a business leader, you could ask your computer the best way to allocate some resource or streamline some logistic process, and you could get that answer without needing to be an expert. That's kind of what we're doing with AutoML. So can we do that for optimization? And if you can do that and bridge this usability gap, then we can make optimization modeling a lot more common. And it's not going to push optimization experts out of their jobs any more than the availability of ML algorithms pushed data scientists out of their jobs. It actually created demand. It created excitement about it. It created demand. It created new applications. It made organizations smarter. And I see that happening for optimization. Yeah, you might not spend your time doing the really mundane parts of it, but now we can focus on the really challenging parts of the optimization, and it'll become a more used, as it should be, used algorithm.
And Warren, I've thought of a question. Back to UPS though, I'm afraid. I've been sitting here really thinking about what you said. The network problem and the routing. I always felt like the operational research side was a bit like an operational research. So it's kind of in the lab and you come up with some answers and then you talk about it. And I've just been wondering about the continuous movement of I don't know what, vans, mail, and all of these component parts. My question is on like the timeliness, where within what time frame a model needs to be applied, refreshed, and so on and so forth. Do you have a view on this, or do you like? I don't know. Is my imagination correct? So I'm wondering. I'm going to ask Warren: are UPS like refitting an optimization in what, near real time, as the drivers have their devices and they kind of move around? Is this kind of thing running non-stop as all of these elements are moving, or is it more like, a big plan happens overnight, it gets downloaded to all the handsets that the drivers have, and they kind of follow it? How can these things adjust, or how quickly can they adjust themselves?
Sure. So the timeliness, it depends on the industry, but and again, I left UPS in 2011, but I can tell you it is either real time or near real time. And one of the great things about getting a system that is widely adopted, that uses this type of optimization, is that you can make near real time decisions that will allow you to be more flexible in pickups and deliveries. So you can imagine that if you were already a driver for a delivery company, you're an expert. And so when we talk about the traveling salesman problem and we say, oh, well, it had trillions of possibilities. Well, that's a little much of an exaggeration, because even though it technically had trillions of possibilities, even someone that's not an expert would look at a spatial map and be able to come up with something that's probably within 10% of the optimal solution. And an expert, somebody that's been doing this for 5, 10, 20 years as a driver, then they're probably coming up with something that's within 1 or 2% of the optimal solution. So there was a lot of change management at UPS to get the drivers to give up that feeling of control and put it into the machine. Now, but what that allowed is that those drivers had that route in mind as they started that morning. They looked at where they needed to go, but you get them to give up some of that control. And now, if a retail customer has a new package that needs to be picked up at 10:30, UPS can insert that in, and it can get picked up, and it can come up with things that the driver would not do. Like an example of that would be, there are certain time delivery things that maybe something has to be delivered by 10:30 in the morning because a customer paid extra to have it delivered by 10:30. The drivers, the non-intuitive answer might be, if I come to a place and I deliver a package that is, and I have two packages, one that has to be delivered by 10:30 and one next door that doesn't have to be delivered by 10:30. The driver used to deliver both of them, but now, because the system knows that even if they take 2 minutes to deliver that to the next door, they're going to be 2 minutes late on another package, that it's better for them to come around and deliver that package later, so that they can meet all the criteria. So those are the types of things that once you get a system that can do near real-time things, then you can start adding new capabilities and new products to your portfolio that are much easier to implement and lessen the change management in the future. So that's basically a long answer for that one, but they do it near real time. Most companies will try to get things as fast as possible. But if you're going to do if you're planning your manufacturing for a month, you might not need to be as fast, and as sometimes you have to be faster. You have to do some heuristics that don't get you the true optimal. So it's really a trade-off between how close you want to be to the optimal solution versus how fast you want to make it.
I understand it. Hey, Warren, we've overrun on this exciting topic. So look, thank you for taking us through it. Thank you for your insights. Ladies and gents, this has been ML's Like Team Spirit.